So Abdel will be talking about modern development of cloud applications with Serverless Weaver. Welcome, Abdel.
Thank you very much. Yes. That's as much Greek as I'm going to speak today, okay? I want you to understand what I'm talking about. So my name is Abdel. I'm a developer advocate at Google. I mostly work on stuff around cloud and Kubernetes mainly, but I've been actually a Go developer for a while. Hence, I am involved in this project called Service Weaver. So, I mean, this is probably the sixth talk this week that talks about microservices and monoliths, right? And I'm not going to bore you with this more than you need to hear about it, but it's a fact that microservices are popular, right? People write microservices all the time. And it's also a fact that there's a lot of technologies that people use to write microservices, right? Docker and containers, Kubernetes, Argo CD, telemetry for monitoring and observability, et cetera, et cetera. But it's also a fact that there is no right or wrong way of doing microservices. Actually, there is no proper way of doing microservices. No one really knows. You ask two different people the same question, you will get two different answers. And so what we did is we went to Y Combinator and we looked at like one popular thread which talks about microservices and monoliths, and we found all sorts of answers. Some people think microservices is a panacea, which is, it's not simple because it's simple to start with, but it's not simple because microservices are distributed. Some people think that they are doing microservices the wrong way or for the wrong reasons, or they're not drawing boundaries between microservices. So one of the main questions that people get asked when they talk about this is how many microservices is the right number of microservices? I mean, and if you ask people this question, usually you get thrown at a number, 10, 20, but like why 10? Why not 19, right? Why not 22? Some people are just think that microservices are just an anti-monolith thing. People do microservices because they don't want to do monoliths, because monoliths are not cool. All the cool kids do microservices, so they just do microservices because we're cool kids. And if you do monolith applications, you are usually looked at as an old, gray-haired person who writes mainframe code, right? And some people think they are not bad, but just people don't know what they are doing, so they do the wrong thing, etc., etc. I'm not going to go into more details. If you look at the big tech companies, they come every 5 years with a new opinion. Uber a few years ago went with, we're breaking out our monolith application to a microservice. And then Etsy also moved to a microservice environment. Same thing for eBay. And then AWS came out in 2019 with this article where they said, microservices are bad, we're going back to monolith. Does anybody remember this article? Right? Anybody wrote this article and the first thing they thought about was like, why was it actually a microservice in the first place? It shouldn't have been designed that way. Without going into details, right? You read the article and you're like, but why did you design it this way in the first place? Like, that was dumb. Anyway, the point here is, this leaves people who are not working for big tech companies with a lot of confusion. Like, how do we design our application? This is the one I was talking about, not the one before, the video streaming one, right? Anyway. So, there are a bunch of challenges when you are doing distributed programming. Again, microservices versus monoliths. But one of the main challenges is how do you get started? Do you start with the monolith and you break it down? Or do you start with microservices and then you combine them, right? Microservices are neither good, neither bad. It's a trade-off. The more services you have, the more challenging certain things become. Telemetry, management, deployments, observability, etc., etc. And the reality is, we live in an environment today where we deploy in cloud, and cloud is inherently complex, right? Of course, if you do stuff in your server, in your basement, under your office, probably this talk is not for you, because you're probably just writing code, compiling a binary, SSHing into a server, or maybe RDPing into a server, uploading a binary, and that's it. So, but a lot of people are using cloud, and cloud is complex. And there is a thing that we don't actually talk about very often in our community is, by community I mean the tech community in general, is that everybody has opinions, right? And the best place to find these opinions is obviously on Twitter. So you just go to Twitter and you will find people with all sorts of opinions about all sorts of things. Why cloud is good, why on-prem is good, why cloud is expensive, why it's not expensive. And everybody has biases, right? Those who write code in whatever programming language, they swear by whatever programming language. Those who are front-end, they swear by front-end. Those who are back-end, they swear by back-end. And there are probably 6 or 7 full-stack engineers in the world. So we came up with an approach where we looked at all these problems, and we said we want to solve it by offering people a way to write a modular binary. A modular binary is still a monolith, it's like a single binary, but the code is organized in a modular way, such a way that if we want to break it down into microservices later, it becomes easier. And we want to minimize or delay the decision of microservices versus monoliths as far in the development process as possible. And we want to also focus on the business logic and let something else handle the boilerplate code. All the configuration files to deploy in Kubernetes, all the interfaces to have gRPC or HTTP or REST or whatever, we want to get rid of that. We are also Google, and we invented Go. So we said, well, let's start with Go. So we created a framework called Service Weaver. It's a framework that allows you to write microservices applications that are easy to deploy, easy to develop, and easy to maintain. Performance, support multi-cloud. We are not biased. If you don't use Google Cloud, that's fine. So how does Service Weaver works? It basically tries to tackle 4 different things. How do you organize and develop your app? How do you deploy it? The performance parts, and then how do you orchestrate it with telemetry and login and testing. For the development phase, in Service Weaver world, everything is a component. A component is defined as an interface, a Go interface, right? That you can choose to run together in one process. You can choose to run together distributed in multiple processes, or you can just deploy it to cloud. You write your code as a single monolith application. You organize your applications into, or you organize the portions of your code into interfaces. You implement the interfaces, and Service Weaver under the hood will generate all the boilerplate code, all the encodings, all the stubs, all the things you don't need to do. So let's start with a very simple example. So I have a Go application here, very simple one. And one of the things you will notice with Service Weaver is that I said that in Service Weaver environment, everything is a component, but an application have to have a main component, right? And that component is also considered, the main is also considered a component. You don't have to implement the interface for main. The interface for main is implemented by the framework. But if you add your own components, then you have to define the interface. Then once I define the interface, I have a type struct in which I implement my main interface, and then I write my function. This is a function that does hello world. So if I go here, I can just do a Go build to build the code, or I can just straight do Go run. And this will just run my application. Nothing too fancy, hello world, not very impressive. Let's look at something more interesting. So if I go here, I have another example that has 2 components. It has the main component I talked about earlier, but it has another component called the reverser. So the reverser is defined as an interface. Basically, by the way, all this code could be in one file. I just split it in different files for readability reasons. So I have an interface called reverser. It has a single function called reverse, and I implement this interface. Now, this will basically tell Service Weaver, the framework, to generate all the boilerplate code, all the underlying code that I need to make my main component talk to my reverser components. In the main component, in order to import or use the reverser, I use this spec here. Reverser, I declare a reverser, and I say weaver.ref reverser. So this will tell Service Weaver that this component, which is the main one, talks to the reverser components, right? Now, if I go here and do a Go run, very basic Go run, I will have a local process running. In that process, I have my 2 components, the main one and the reverser, right? They're all running in the same process. So the Weaver command line has a way for you to see what's going on. So if I do Weaver single status, it will tell me I have a single deployment, and in this deployment, I have 2 components, and these are the process IDs, right? And then I have a listener. So what is a listener? Weaver is written with the idea that applications that you are developing are HTTP applications or are endpoints, applications that you need to call from outside. So we added this concept of listener, which declares here a listener that listens on port 1, 2, 3, 4, 5. So this file called weaver.toml is just a tiny configuration that allows you to tell the command line how to compile, how to deploy, and how to run your application. So in the first statement, I always have a Weaver statement in which I say I have one binary, and the binary is called hello. So basically, when I build this app, the binary that will be created will be called hello. Then I have a statement here called single, and in this statement, I have a listener, which listens on port 1, 2, 3, 4, 5. So if I go to my terminal, so I have it still running, good. So if I do a curl on this thing here, curl localhost 1, 2, 3, 4, 5. Is it on this one or this one? Hold on a second. No, sorry. If you run it with Go, it will listen on a random port. If you want it to listen on the port that I defined in the weaver.tml configuration, I have to use the Weaver command line. So I can do Weaver single deploy weaver.tml. So this will spin up my application and make it listen on port 1, 2, 3, 4, 5. So now if I do a curl on this, I don't get anything, but I have to go onto the endpoint called hello. And then I have my response. So what happened now? Basically, I called Weaver, I ran the application. I called the endpoint called hello, where I have an HTTP handle. And then the endpoint, I could also pass a word, so I could do something like s equal Devoxx. No, not that way. Sorry about that. I forgot the syntax. Sorry? Name. Yeah, you're right. No? Interesting. Okay. I will, give me a second. Let's see if I load it into the actual browser. I think it has a web interface if I am not mistaken. No. Localhost 1, 2, 3, 4, 5 / hello. Yeah, hello world. Okay. But how do I pass different things? I forgot how this one works. How this particular example. I'm not there. I'm there. And okay, that's great. Oh. Let's see. Let's use this. I think I have some. I had this problem earlier. I think it has to do with the ZSH not liking those special characters. I think I need to do. Yeah, here we go. Yeah, now it works. So I just had to escape the special characters. Yeah, so if I do something like Devoxx, and then it will be reversed to Vox, right? So what did I do? I have a main component which declares an endpoint called hello. It expects a parameter called name. If the parameter is empty, it will replace it with world. And then it calls the reverser, which is the other component. So it basically calls the reverser with the reverser.get, calls the function reverse and passes the parameter, and then the reverser will just reverse the word for me. So if I go back here, not here. If I go back here and I do something like Weaver single status, again, I have a single component, a single deployment, which has 2 components. You remember when I said we want to be able to delay splitting up your application as much as possible? What I did right now is I wrote an application and I run it as a single binary. So it's technically a monolith application. What I could do is using the same application. I didn't change anything, right? I just have another statement here that says I could also deploy this as a multi-deployment. And then I will run the same command, and now I have two different components running, or two different apps, or two different processes. So if I do multi-status, then I have basically two different PIDs. Do you see the PIDs where I have two? That's because for each component, I have Go itself, and then I have the component running. So I have two different applications technically. You can think about those are two different microservices, right? I did not change anything. I did not touch the code. I did not change anything. I just used the same command line, but say instead of deploying it as a single process, now I deploy it as a multi-process, right? So that's essentially the kind of core part of Service Weaver, is this ability to write your application as a single binary and then split it up later using Service Weaver itself. And when I deployed my application as multi, then Service Weaver generated under the hood all the HTTP code, all the REST code needed, all that stuff, so that the two applications can talk to each other. I don't have an open like an open API YAML definition file here. I don't define any interfaces. I don't have any APIs. Service Weaver like took care of all of that stuff. I'm going to show you an example later for Kubernetes, which will be more visible. So yeah, just to recap, I write my Go interface. I implement it in a struct through the weaver.implements, and then I write my function. And if I need to instantiate it or call it, then I need to call the weaver.ref, specify which components, and then call the weaver.run to run the application. And then if I need to interact with the components, I just call the component app.cache.get, and then .get is the actual function, that the actual call that will call the remote function or the remote application. So for deployments, we talked about releasing as a single binary, so I showed this. I can also deploy it as a multi-binary, or I could deploy it into Kubernetes, and that's the example I want to show next. There is also a deployer called SSH. You could just define a file called sshlocation.txt and list all your SSH destinations with the keys, and then you can run a Weaver SSH deploy, and then Weaver will generate the binaries and will deploy them into the remote. If you have like multiple servers, you want to deploy to multiple virtual machines or whatever. Yeah, so the Weaver SSH deploy. So in Service Weaver world, those things are called deployers. So we implemented a couple of deployers. One of them is the local deployer. One of them is the SSH one. One of them is the Kubernetes one. But deployer is an interface, so you can implement your own deployer. If you want to deploy to, we also have a deployer for Cloud Run, which is Google Cloud. But if you want to still use Service Weaver, but deploy to like an AWS function, or to AWS Fargate, or to Azure Container Services, or whatever, you can just write your own deployer. We did also write a generic deployer called Kubernetes, and that's the one I want to show you. So what we can do is I can go here. I'll show you the example. So I have this application here, which is like a chat app. It has a bunch of components. It has a SQL database. It has a server. So the server is the main components that we have to look at. That's like the main thing. It has that's the main function, and then it has 3 references. So it relies on a SQL store, an image scaler, and a local cache. So this SQL store is the component talks to the database. The image scaler is just a component that takes because the application allows you to upload an image from the front end. So we take an image and we shrink it down. We resize it. And then the local cache is a cache component. And so here in the code, I have the SQL store code. So that's the component that talks to the SQL database. I have the thumbnail code. So that's the component that shrinks down like resize the image. And then, yeah, that's it. So, and then I have the cache component. So this is the caching component. So each component is its own file. And basically the server is the one that just kind of puts them together, right? So I'm not going to bore you with the code. I think this is all in GitHub, so you can read it later. So in my Weaver declaration again, I say I want to build a binary called chat. I have some stuff here. This is just like to tell the application how to connect to my database. And then I have a single and a multi. So I can deploy the app as a single component like we did earlier. So I can show it that really quickly. So Weaver single deploy Weaver.toml. Oh, no, okay. I don't have the last version. It's okay. I don't have to show that. I'll show you directly how to do Kubernetes. It's easier. So for Kubernetes, we created, so sometimes also when people do Kubernetes, what they want to do is they want to be able to customize the deployment itself. So you can define your own resource requests and limits. You can do all the stuff that Kubernetes allows you to do. So instead of building it into the TOML configuration file, we created a new configuration file called YAML, because everybody knows that YAML is the best configuration language in the world, right? Right? Good. It's everybody's favorite programming language. So in the YAML file, you define the waiver.toml, so you tell the application where is the configuration file, so it still knows how to build it. And then you define a repository. So this is where my container image will be uploaded. And I say I have a chat. I have one listener, which is a chat listener, and it's public. By default, all the listeners in Service Weaver world are private. If you want to expose something to the internet, then you have to precise it's public. So just to be clear that you understand, I am not cheating here. I do not have a Docker file, right? I'm scrolling up. I feel like I am a... Or not. All right.
Sorry for that.
Thank you. Upload for the technician. That's live troubleshooting at its finest. All right, so now I want to deploy this. So what I want to deploy to Kubernetes. So what I do is I call Weaver, not Uber. I have a kube deployment instruction, and I can just say deploy. Deploy. And then I specify the configuration file I talked about earlier, the kube deploy.yaml. So this is going to build the container image. It will push it to this remote registry. You could use Docker Hub, you could use any remote registry you want. This is a Google-specific remote registry, but Service Weaver is agnostic. It implements the Docker API registry, so the client can upload to anything that is Docker API compatible, right? And then I have my listener. So what happened? I have my app that was built and pushed automatically. Again, not using Docker file. This uses, if you are curious, it uses something called Canico, which is a Go framework for building container images without Docker files. If you are also curious more, there is a lot of ways to build container images without the need for Docker. If you're a Java developer, you can use Jib. If you are a .NET developer, they have their own plugins. There is like multiple plugins for build tools that allows you to generate a Docker file without using Docker. And I'm not saying this because I don't like Docker. I'm just saying that not everybody needs it. So I have my image here, which was pushed. It only has 6 vulnerabilities, so not too bad. And then the command line Service Weaver generated a YAML file for me. So if I go click on this YAML file, if you are a YAML fanatic like myself, you're going to have a very good time. Because here I have all the components I need to deploy into Kubernetes. And when I say all, everything. I have the role bindings, I have the configuration files, I have the deployments, the service, all that stuff. You remember earlier when I said that in Weaver environment, every listener is private unless you specify otherwise? The reason why we had to do this is because we need to expose one component, which is the interface, like the web UI, and that's essentially this one here. So it created one service which points to the chat app, and it exposes it on type load balancer. For people who know Kubernetes, you know what I mean here. For those who doesn't know, this just deploys the load balancer, right? Everything else will be private. So let's go ahead and deploy this. Let me make sure first that my, oh, of course, I have stuff deployed there. I have to delete that first. Oh, delete. Let's hope that this file still exists. Okay, good, good. Okay, good. And then I just do a kubectl apply -f on my YAML file, right? And this will deploy everything for me. So if I do a watch kubectl get pods, then I will have my containers there running at some point, and eventually at some point I will have a load balancer. That will take a little bit of time, so we can, no, it doesn't actually. That was fast. All right, cool. So if I go here and try to open this IP address, I should hopefully have a chat app loading. Hopefully. No, no, okay. So that was the previous one, which was being deleted, so it's creating a new one. This is going to take a little bit of time, and I'm going to come back to it later. But the point I want to leave you with is I wrote a very small configuration file in the form of YAML, and then I used Service Weaver to generate everything else. So create the container images, upload them, generate all the YAML files, generate all the configuration files, generate all that stuff. So if you really don't like Kubernetes and you don't like writing Kubernetes YAML files, this is a great way to avoid doing that. And then when I was talking about the YAML file earlier, one of the things we added to it is the possibility to customize your application. So you can do things like this, for example. I can specify the resource requests and limits. So I can say my application only can get like 46 megabytes of memory. I can say this one gets 256 megabytes of memory. And it will also generate automatic telemetry. So it will have Prometheus with the metrics exported automatically. It will have tracing. It will have everything. I'm going to show you some examples in a bit. But I can basically start with a simple 4 lines, 5 lines YAML file, and then I end up with like a full deployment on top of Kubernetes. So now if I go check on that chat application, it's working. I'm not going to try it out because I don't have that much time. But yeah, I have a chat app. So basically, this is Kubernetes without the hassle, if you want. So the last thing I want to show, maybe it's going to be the last thing. I want to leave time for questions. Let's see. I think I'm going to skip through some of my slides. I don't need to show everything here. I'll skip straight into, yeah, we did actually some benchmarking. By the way, I think this is interesting. We did some benchmarking to figure out, like, is Service Weaver actually way better than other stuff? And what we did is we run it against an application that exists. We have this demo app called Online Boutique. It's an app that we usually use to demonstrate Kubernetes and GKE and all our products. It has 11 microservices. And when you run it as is on top of GKE, which is our managed offering, it uses E2 machines, and this is the benchmark at 10,000 loads. This is basically what we ended up with. With Service Weaver, which is on the black side, on the yellow side, we have less code, right? So basically, we took the application, we rewrote it, and we ended up with less lines of code. I think it was like from 3,500 down to 2,000 lines of code, right? Because again, remember, we remote all the boilerplate code, all the stuff that you have to write or you have to generate, that's generated by the framework. There are 0 configuration files. On the right side, you have the benchmark, right? Because we are able to generate all the stubs and all the underlying HTTP components, we can optimize those very well. And you can see there that it consumes, so the application using Weaver consumes less CPU, and the latency on the 99th percentile is way less than the actual application. So this is running the benchmark, which is at 10,000 requests per second. So telemetry. The application will have logs automatically. So as long as your application logs out to standard out and standard output, we're able to catch those logs and stream them to wherever logs has to go. Metrics are Prometheus style metrics, again, automatically exposed. And we also rely on OpenTelemetry for tracing. So you have to just instrument your application with the OTel agent, and then we will expose all the traces automatically. So let me show you an example of this. If I go back to my Hello app here, I can do Weaver multi-deploy, deploy Weaver.coml. So this will deploy the application for me, give me that URL. What I can do is I can do Weaver metrics dashboard, multi-dashboard, sorry. And so this will give me this URL. So if I click on it, I have a dashboard, and it already knows that there is only one app running. So if I click here, I have 2 components, right? I have the main component and the reverser. I will have a graph here which shows me traffic. I don't have enough traffic to be able to show it, but the most interesting thing is I have metrics. So if I click on metrics, I have Prometheus endpoint, right, with all the metrics. Again, I did not instrument my app with Prometheus. I did not import anything in the app. Like Weaver automatically injected the libraries and generated the metrics automatically. And then I can also get traces. And so if I load my app, local, I think it's localhost 12345 on slash, is it slash hello? Come on. No, this is not the one I want. No, sorry, yeah, I was looking at the wrong one. But okay, it's in this reverser folder. I could do that. Reverser. Examples. Examples, reverser. And then Weaver multi-deploy. Weaver.toml. Okay, the app is running. It's running on this IP address here, so it's on port 9000. Okay, cool. That's the application itself. Then I can try to get the dashboard back up. So if I do that, I have it here. Okay, I have my reversal application. I have the metrics again, but what I wanted to show you is traces. So if I go here and say hello or yes, is that how you write yes? Yes? No? Okay, sorry about that. So if I go here, I see all the traces, right? Because each time, because the way this app works is each time I am typing on the left side, it makes API calls to reverse the string on the other side. So it generated all these traces, and if I click on one of them, it will just upload the trace to Perfetto, and then I have my trace, and I can look at it. So I can click here, I can see that a trace goes to the Weaver components, and I can see like a bunch of information. It generates automatically the span IDs and all this stuff, and yeah, that's basically it, I think, as far as at least as far as tracing and observability goes. So the app, basically Service Weaver automatically instruments your application with traces, metrics, and logs. That's the TLDR. There is also profiling. We can do like live profiling on applications in Service Weaver. Yeah, I want to skip through a bunch of these slides. I think there is one slide here which would be probably interesting for you if you are curious. I have to find it. I don't know where it is, and I might just skip it. Okay, yeah, I will. Yeah, here we go. So basically, this is the core of what Service Weaver does. You focus on writing components. We can deploy these components as a single binary, multiple binaries, or multiple containers on Kubernetes, and we add the Weaver library under each of your components that makes the communication between your components happen. That Weaver library is the underlying gRPC code with the stubs and all the boilerplate code again. And that's it. That's all I have actually for you. So I will leave you with one slide which will contain the link to the documentation, and it is this one. So I'd be happy if you give it a try. If you're a Go developer, you can scan the QR code. It will take you to the URL. And if you like to contribute, please do. And if you want to give us feedback, please do. Just please be nice. And that's it. Thank you very much.
Awesome. Thank you.
I should have asked the question before I started. How many here are Go developers? Ah, there are a few of you. Good. All right, cool. It's good to see Go developers in the wild, because you don't see them that much outside of Google. Cool. Did you find it interesting? Okay. Are you going to go try it out? Maybe not this weekend. You're too tired, probably. Right.
So more Q&A. Anyone? Any questions for our last guest of the conference? No? Everybody's a bit too tired? We have a question over here. Awesome.
Definitely, yes. I think it's, yes, definitely, you can. I mean, so there is the equivalent, which I tell people all the time, because Service Weaver is not very known, but the equivalent is Dapper, the Microsoft one, and that supports a bunch of programming languages. It functions at a different level, but that's like an example of like, I mean, there is other stuff for other programming languages. Service Weaver was designed specifically to be Go specific, because then when you are developing this kind of frameworks, one interesting thing you have to keep in mind is, do you want them to be generic enough to support multiple programming languages, or do you want them to be specific so you can focus on optimizations and performance and stuff like that, right? Service Weaver wanted to be specific to Go so we can focus on optimizations. But yes, you can take the same idea and just build it for a different programming language. Right? Thank you. All right, I'm going to take a selfie because that's...
We have another
we have another question
over there.
Okay, I just want a picture so I can prove to my boss I was working.
That's a good one.
Yes, yes. How production ready is the framework? It's very production ready. It's very stable. Yes. That's it? Okay. Yes, you can use this in production. It's very stable.
Come on, give us one more question. I'm sure you have energy.
There is
Come
one
on.
question here.